Hello everyone, we are Team Exonics, and in this Smart India Hackathon 2025, we have decided to take the problem statement ID 25108, and the problem statement is development of AI-powered FRA at last and WebGIS-based decision support system for integrated monitoring of Forest Rights Act implementation. Before diving into the PPT and the prototype we have developed so far, I would like to tell you why we could relate to this problem. We are from Northeast India, where forests play a major role in our life and in our landmass too. So, as a student, we have all faced delays in application response results. It's been frustrating to receive a message or a response very delayed. Imagine that for a fundamental thing like land. So, moving on to the things that we have been able to do in this prototype, I would like to give a summary of what we tried to solve in this problem statement. Okay, so the problem was over 1.8 million FRI claims remain unprocessed. Delays, disputes, and poor visibility. Government struggles with tracking, monitoring, and evidence-based policy design because it's very massive in scale, right? It's very impossible for government to do these things. It's such a scale, and communities too wait years for transparency and representation of rights. So what we have did is we have designed an AI assisted claim digitization. What it does is we have an OCR and NER to extract data from scattered manual records with 95% accuracy. We also have an interactive WebGIS dashboard. What this does is it doesn't give a static map. It gives an interactive map where the claims can be tracked in the maps. The claims are visible in the maps. Also, we have a decision support system. What it does is it gives scheme recommendation with transparent why logic. That means it recommends a scheme which is applicable for the particular, but it also describes why this scheme is applicable to the uh, village or the area, which is we believe is our unique thing that we have decided to implement in this project. And the fourth is multi-stakeholder access. By multi-stakeholder access, I mean this platform will be available uh, to be accessed by governments, of course, governments, NGOs, and community heads with role-based permission. For the current prototype, we have designed it particularly for the government and those the department that will be seeing this. Uh, but I believe in the further part of the prototype, we'll be mm, working on different role-based system how this platform will look in different roles. Right. And the uniqueness and innovation, the thing that differentiates us from the rest of the applications is first of its kind FRA DSS. As I told earlier, the DSS is an AI platform that is dedicated to forest rights data and policy recommendations, and it also explains why. And the third is, and thus, I mean, the second is human in loop quality assurance. What it does is, we have a confidence scoring. Suppose a claim has been, uploaded in a platform, and the OCR and NER extracts data from the claim. And suppose our system couldn't extract the data 100%, so it will show a low confidence level. What it does, then the reviewer or the ministry or the government who will be reviewing this, I will call this as admin in the whole video. The admin will review this and manually, and after reviewing it, it will give a yes signal, a positive signal, which will provide the link option in the in our platform, and then the admin can link or the AI will link the map to which the document is being pointing. Right, in the map, then we can see the that this document has been uploaded by this person from this village, and this is the document. So what we did, we introduced human in the leap to be the tiebreaker in where, if any situation arises where machine fails, then the human can manually review it and help the for the scheme implementation and the rest of the things. And the third thing is future vision. It lays a foundation for welfare planning and policy research. as mentioned in the problem statement, speeds claim processing by 60% and drives data governance for 200 million plus tribals. And now the feasibility and viability of this project is, it's the feasibility of the idea is its government alignment, centralized FRA claims and forest land tracking, better scheme design, as mentioned earlier in this video, and proven tools like WebGIS and AI, uh, pilot to scale. First, we are trying to implement this platform on a district level pilots and then expand to state or national level. And again, the most important part that is social impact. It enables targeted policies, transparency, and faster claim resolution.
Dive into the prototype itself first. So this is our prototype. First, we go for the dashboard. In the dashboard, we can see the total claims are 13, the pending are 4, 6 are linked to the map, and 10 villages that we have accounted for. This is our interactive map that gives you the visualization of how it looks. Suppose this is a random village here. So here, as we can see, this is the village demarcation. And suppose we have gone for this review here, Rahul Singh, which holds 509 hectares in this village, and the date that it has been linked is 4/09/2025. Suppose we want to review this data. So here we can review it directly from here. So we can see here the document review is here, that gives you the pure data, what the claimant has filed here. This is the claimant name, patta number, the extent of land he holds, the gram panchayat, tehsil, taluka, the claim types, and whatnot. And also we have come for the confidence scores aside, which gives the reviewer the clear picture of the data that has been extracted is correct or not. And if not, it can directly correct it by itself. Here, suppose we have gone for a mistake here. Suppose the land that Rahul Singh holds, it's not 509, but just 59. So the admin can directly alter this and come across with this 59 here. So it's done and it will save changes. And now for this, it can directly show that he holds 59 hectares here. As simple as that. This gives you a pure visualization of how our system will be much efficient to use as to the normal day. Suppose we have gone for asset layers. Here we can use for water availability, for forest cover that the village holds, and for the agricultural land that the village holds. So this will give the pure visualization to the policymakers where and what policies should be implemented. And suppose we have gone for claimants list here. In the claimants list, we can directly search the name. Suppose right now we gone for Rahul Singh. So here Rahul Singh, we can go for the search for the types of it, the IFR, the CFR, the CR. Suppose we have gone for IFR and just get into it. So IFR, all IFRs. For status, suppose the linked that are visible in the map, can directly go here. Suppose which needs to be reviewed, can be reviewed here. Suppose that needs review here, that is unlinked, no one's unlinked, and the rejected ones, no one's rejected yet. So yeah, all types. Now status here. After that, we can go for the villages. For villages, we can directly see that the list here also appears. And after that, we can go for village analysis. This is our DSS recommendation that will give you the clear picture of how our engine works. Suppose we go for a random one. Suppose this is Kakra one. From here, we go for 2 claims. The pending claims are 1, the CFR, IFR 1. So the water coverage is 34%. The forest coverage is 53%, which is staggering. The agricultural land is only just 18.5%. So the agricultural land area is low. So to prevent it, Pradhan Mantri Kisan Samman Yojana, 70% of farmers are smallholders with less than 1 hectares, facing input cost burdens. PM Kisan supplements income, enabling better seeds, fertilizers, and reducing distress migration. So you see, it gives you the why it needs to be implemented here also. So after that, We can go for the predictive analysis. This is our USP for the project. Suppose we want to see a normal village, suppose here Melargar, and we want to see the forecast for the 12 months. So we have gone for a 3:1 approach. 3:1 approach means that the three parts will be from the previous data, the historical data, and the one part will be the forecasting data. So here, this will forecast the rainfall. Suppose as we can see here, this is the historical data that was recorded in the Melargar, and here, from here, this is our predicted data that this much rainfall will be there, and it's not just for rainfalls. We can see for water availability if there is scarcity of water, for vegetation health, for deforestation risk also, and this is our community assets here. This community assets is also our USP because we have gone for the human in loop quality assurance for the quality assurance. So here with the community assets, we can directly add if the satellite is unable to locate a certain thing that was not catched by the satellite itself. So the admin can directly add the new assets. Suppose a school is added, a new water pond is added, a borewell, or let's say a very big pond is added in the community. So he can directly get here, select the village, suppose here, suppose asset types is water body or forest area, suppose, and then he can give the description here. He can directly drag and drop or select. He first has to give an evidence that the forest area is there or the pond or the water body is there. So he has to give first, he has to give the evidence, and then only it will get assured. So here, this is our prototype. Hope you liked it. Thank you very much. This is a closure from Team Xionyx.